Okay, so hello everyone, I am K S Anupama and today I will teach you maths. So this is my first video on maths. So today we will be discussing about relations and functions. It's an easy chapter and mostly questions are asked from the MCQs. So just understand what I'm talking to you and also understand each meaning, because if you understand the meanings you can definitely score well. So let's start. So first one we will see is ordered pair. So basically I have already written there are totally 8 marks can be expected from this chapter. A pair of real numbers a and b can be written in between two common brackets, means there are two elements a and b. So these are elements. So how you say these are the elements and all that. So a pair of real numbers a and b are terms we are basically using to represent the real numbers, can be written in between two common brackets using comma, means these 1 and 2. Let's say example 1 and 2 are the real numbers if we are putting on an example. So these can be written in a bracket. In the bracket we can put 1 and 2. So using a comma we can separate them. Okay, so it basically we're talking about this a comma b or a comma b. So these two things, as you can see, these are the same meaning. You can write capital or small, because in the maths terms when we are talking of alphabets to represent the numbers, it is not like compulsory to put only capital only. You have to put small letters only. So we are just talking about understanding the topic. So that's why you don't have to worry about that. But still these are the that only is written here, where a is the first element, means a here can be this a or can be this a as well. So anything. So you can take it's not like you have to take a and b only. You can take x and y. So it's not like you have to compulsory take that. So a is the first element, point on the x-axis. A is the first element, so point on the x-axis. B is the y element, y, it point on the y-axis because it's the second element. So basically in putting a graph in your past years, you see first element whenever you are putting on a graph, first element is what? X. It's basically meant for x-axis, x-axis, and the second element is meant for what? Y-axis. So that's only we are talking about here. Cartesian product. So mostly in this 2025. So in 2025, yes, they asked one question for all. This sign is meant for all. Okay, so they asked you what is this. The first question is that only in Karnataka State Board 2025 they asked this question. So a and b are two non-empty sets. So a and b are basically two, in simple ways I will say a and b are two markets. Okay, so these have two non-empty sets, means they have something in there markets. Okay, I will tell in simple ways. A is a market, B is a market, they have something in here, they have something in here, but they are not empty. Okay, so the Cartesian product of two and A and B. So if these markets collide, so what will be the elements? So like that way you can think. So A cross B, in bracket we can see A comma B are what? These are the elements of this particular collision, like a Cartesian product. So for all A belongs to A, means A is what? Elements belonging to set A. So let's say A is Anupama, me. A, small a are the elements I have in my market. Okay, B is you. Okay, B is you, can assume anyone. Okay, if I don't know your name actually. So B is you. B, small b is the number of elements you have with you. Okay, so the A, small a, is the elements I have, so it belongs to me, belongs to my set. And the small b, the elements you have, it belongs to set B, means you. Okay, this is belongs to sign. Okay, so another one example I will say, So elements 1 2, elements 1 2 are what? These are set A, small a. Okay, element B is equal to A comma 3. Okay, these are your set. Okay, A cross B, if we cross both of these, so what we get? So the first element is multiplied by the first element, what we get? 1 comma 2, so AB. Okay, and then another one 1 3, if it is multiplied we get what? Subset, which is 1 comma 3. Okay, and then the second set is multiplied, second element of set A is multiplied by first element of set B, so what we get? 2 comma 2. And then the second element of first set is multiplied by second element of second set, second element of first set is multiplied by second element of second set, we get 2 comma 3. You don't understand it, I understand. See, in simple words, 1 is multiplied by 2, 1 is multiplied by 3, we get 1 2 1 3. 2 is multiplied by 2 and 2 is multiplied by 3, we get 2 comma 2 2 comma 3. So basically these are the possible subsets. Subset, why we call subset? Because these are specific, this is specific set we are dealing with, and this is specific set we are dealing with. When we combine both of them, so we get another small sets which we call as a subset. Okay, after the sets we get by multiplying two major sets is called as the what? Subsets. Okay, so you have already learned it in your 11th. Okay, so in simple words I am talking to you, because they not ask the definition or anything, but still you have to understand. A relation R on a set A is defined as subset of A cross B. If A is related to B, it can be written as R is equal to A comma B. A relation B is true. A is related to B. Okay, so in example I will say, you won't understand anything anyways because it's really confusing. Whenever the students are talking about sets, they don't understand what we are talking about, so that's why. So I will give example. So I already told you how we got this multiplication and all that. So let's see in simple words. A relation is basically when we cross to C, A means my set, B your set. When we cross, we got subsets. Like subsets are what? The basically 1 2 1 3 2 2 2 3. We got this subsets. So the markets are merged and we got subsets, means the profit, as we can see, R is equal to A comma B. Means A comma B is what? A comma B can be the set from this particular A cross B product. Okay, if A is equal to B, let's see, like we are putting on a big mela. If we say the people have specifications, like they want only this product. Okay, so what we see, that they specifically point out this only. Like that, R is equal to, which a relation says that the set major set what we got, like after crossing the A cross B means a Cartesian product, we got a big set, this one, like as I show you here. In that they specifically want a set, this is a set, in these they want a set where the element A is equal to element B. Okay, these two should be the same. We have to find that. So in this set what we see, element A is equal to element B. In this one is similar, these two are equal because these two are same number. That's why this is the relation. Understood? Its subset is what? In this specifically bigger set, in that it's a small set. That's it. Okay, so set, if you are seeing what is set and all that, you don't need it, but see, this the elements which are written in a bracket, the elements which are written in a bracket as flower bracket, they should be specifically flower bracket, and if you are referring to a subset, it should be in the open bracket. Okay, so the specific element, they can be two types of set. One is finite set, one is infinite set. Mostly they ask is finite set. So remember that. Okay, so relation is basically what? Specification. We have to put see the set, basically the Cartesian product what we got, and then we have to specifically take out the subset which is relevant to the relation. Okay, another one is A comma B. A comma B is what? Subset. We are basically finding a Pokemon or something. We are finding something. So if A is less than B, we have to in the basically a market, we need to find a subset A comma B where the first element is less than second element. So in that case, in this specifically market, see, this is a market, let's assume in this which element the first element is smaller than second element. First element is what? This first one here is less than second here. See, this one is true because the 1 is less than 2, and here is also true, 1 is less than 3, and this one is also true because 2 is less than 3. So these 3 can be written as in this particular category. So that's why. And also this is subset. Subset, it's belong to A cross B. So it belongs to the A cross B. That's what they want to say. And then A comma B means we are finding a Pokemon again. Okay, A cross B. A cross B is a subset. We don't know what we have to find in the subset. If A is greater than B, means the first element should be greater than the second element. In this particular market, how can we find? So basically I'm telling market because so you can understand. Okay, so in this particular set, see where in which case first element is greater than second element? No, there is not. Okay, there is nothing. In some cases they can be there. I mean another thing, they can ask you in some case they can ask you if A is greater than C, if A is greater than B, like that. Okay, they can ask any particular number sequence. Okay, they can be 4 elements, they can be 5 elements in a subset. So they can ask you A should be greater than D, A should be greater than C. So that you have to assume. Another thing you need to remember, the A cross B, if there is an element A, B, C, D. Okay, A, B, C, D. If it is 1, 2, 3, 4, okay, all the subsets you will form is also in that particular order only. Means 1, 2, 3, 4, 1, 2, 3, 4, like that only. So it's not there should be specific same to same number, but the sequence 1, 2, 3, 4 are A, B, C, D, A, B, C, D, that should repeat. Okay, in small set A, B, C, D, like that only it would repeat. Okay, another thing, so this one they won't ask as I think so, but they will ask you in your MCQs. Okay, they specifically ask for MCQs. So the total number of subsets means A cross B. A is a specific set, B is a specific set. So the total number of subsets means these what I told you, these small elements 1, 2, 1, 3, 2, 2 and 2, 3. So these elements, how many can be formed? So to calculate that, there is a simple rule is that 2 to the power of m cross n. So m cross n are what? Elements A and B. See, read that first line. A and B are two non-empty sets, means they have something. So consisting of m and n elements respectively. M and n, A have m number of elements, B have n number of elements. So the m and n, if we multiply the m, means the total number of element in set A, and if we cross by second set, which is B, the total number of n number of sets present in set B, if we cross them both multiplication, so what we get is the total number of subset. You don't understand, I will tell you. See, the total number of the cross product I already wrote. I already told you. Total number of elements. How many elements are there in set A? 1, 2. 2 element, right? In set B, how many elements are there? 2 element. 1, 2. Understood? If we multiply 2, what we get? 2 2s are 4. So 2 to the power of 4 means 2 you have to multiply 4 times. 2 into 2 into 2 into 2. What we get? 16. Simple. Like that. So I will tell again. A have m number of elements. Sorry, I have cold. So A have m number of element m. Okay. So m number means there can be 2, 3, 4, 5, 6. So in this case we have 2 elements. Okay. M number means 2 sets. 2 number of elements are there. And in set B, they have n number of element. Means they have 2, 3 means 2 elements. Okay. Comma is representative. Comma is put because you are talking about like we are separately like A2 is separate number, B3 is separate number, 4 is separate, like that. 2, 3. In this case 2, 3 means 2 is one first element, 3 is another element. Okay. Type of relation. See, this can be asked in your exams. Okay. Type of element reflexive relation means a relation R on a set A is called reflexive relation. That is R is equal to A comma A for all comma like slash A relation A is true. See, if we are talking about relation, as I already shown in a like upper questions, if first element is equal to second element, and these two are specifically same to same, there is no change, then it's reflexive relation. In simple ways, like see, A is a element, it have 1 and 2. Okay, these are the two elements present in two like numbers present in this set. Okay, so if we have like a relation, in that case the subset should be 1 comma 1 and 2 comma 2 only. The first element and second element should be the same to same. Okay, in that case the relation is said to be reflexive relation. Means the A is related to A, means the reflexive relation condition is true. Okay, that's all is about reflexive relation. Means the first element should be equal to the second element, means they should be same to same. Okay, in simple words, you don't have to worry about it. Symmetric relation. A relation R on a set A is called symmetric relation if A belongs to R, then A comma B belongs to R, then B comma A belongs to R. For all A comma B belongs to set A. You don't understand, I know. So basically, let's say we have a set A which have elements 1, 2, 3. So these are the possible relation we can get, like 1, 2. So 1, 2 we can say, 2, 1 we can write. So like that. If we assume A as A, 1 as A, 2 as B and 3 as C. Okay. If we are assuming like that, if we are considering 1, 2 as subset, in that case we have to consider 2 comma 1 as well. So if there is like that sequence in a relation, then we can say the particular set have the symmetric relation. Okay, so if we consider like AC, they should definitely be CA. Okay, if we are considering like BA, if we are considering BC, if we are considering BC, they should definitely be CB. Okay, it's not like you have specifically like this only. In this case, we are talking about AB, BA should be there. BC, CA, CB, BC, CB should be there. AB, BA should be there. like that. Okay, so if there is like that, like 1 2 3, these are the three elements. As 1 2 is present, 2 1 should be present. If you are taking 1 3 as a set, there should be a 3 1. Okay, so transitive relation. Transitive relation, a relation set R on a set A is called transitive relation. If A comma B belongs to R, B comma C belongs to R, A comma C belongs to R, for all A comma B comma C belongs to main set A. So in the upper case, like the symmetric relation, the AB means the subset relations. We are making subsets from what? From the set A only. Basically the only set A. So they all belongs to, like all the subsets number, they belongs to what? They belong to the like set A only, the major set A only. Okay, so that's what when we put these for all, like this side, we are talking about like these all the subsets we have made, they belong to the major set A only. Okay, transitive relation. Transitive relation, a relation on a set A is called transitive relation. If A comma B, as I already read already, so A comma B means the, if we take example 1 2 3, A comma B, B comma C, C comma A, it should be like that sequence. Oh sorry, A comma B, B comma C, A comma C. Okay, same I told you, A comma B, B comma C, A comma C, it should be like that sequence only. Okay, and all the elements like in the set, as I already told you. Let's take an example. See, if we consider 1 as A, 2 as B, 3 as C, so in the relation, like the sequence should be A comma B means 1 2, B comma C means 2 3, and the last one is what? A comma C means 1 3. Like that sequence only, if it is present, then it's transitive relation. Okay, equivalence relation is what? A set which can satisfy all the three relations. Okay, it's represented as like equivalence relation. Okay, give an example for a relation which is symmetric but neither reflexive or transitive. Simply symmetric relation is what? If we are considering A comma B or B comma A, in this like 1 2, there should definitely be 2 1. Okay, and then if we are talking about like 1 3, they should definitely be 3 1, and also if we are considering 2 3, they should definitely be 3 2. Okay, so we are just giving an example, that's why I already like our teacher, I mean our sir have written 1 2 2 1. Okay, so it's an example in this set. So basically like the main how many numbers can be made from this. So these are the total number of sets which can be made by the symmetric relation. Okay, so you can write all of them, it should be a correct answer. Okay, so this is just an example. See, here is also mentioned give an example, means you can give one. Okay, if you are willing to do more, you can do. Okay, give an example of a relation which is transitive but neither reflexive nor symmetric. See, transitive is the relation what? A comma B, B comma C, A comma C. They all should belong to A only. Okay, so in that case, A is equal to 1 2 3. 1 2 3. 1 is what? A. 2 is what? B. 3 is what? C. And the relation what we can make? A comma B means 1 2. And B comma C is 2 3. And A comma C is 1 3. Like that. And a given example of a relation which is reflexive and symmetric but not transitive. See, if there is an element 1 2, there should be 1 1. There should be 2 2. And symmetric means there should be 1 2 and there should be 2 1. So, if we are talking of this, let's see, not transitive. See, another one case I will tell, this is an example, it's right actually, I put in wrong I guess. No, it's right. So, A is equal to 1 2 3. So, R is equal to what we can say, like if we are talking about reflexive symmetric, there should be 1 1, there should be 2 2, there should be 3 3, means same to same they should be there definitely. And then 1 2 2 1 should be there, 2 3 3 2 should be there, and another one is left out, I guess. 1 3 should be there also, but as we see, like 1 comma 2 belongs to R, 2 comma 3 belongs to R. See, 1 3 should not belongs to R. Why it not belongs to R? See, oh yeah, transitive we are talking about. Transitive is what? Transitive should not be there. Means 1 3 means A comma C. If it is there in the relation, then they should be what? It become transitive. But here what they are asking? They are asking that it should not be transitive. So that's why we say that we did not put like 1 3. That it is that reason I didn't understood. Okay, so 1 3 they shouldn't be there, because if we put 1 3 and 3 1, then the relation should become equivalence relation. That's why it will not be like the based on the question condition. Okay, that's why we say that the 1 3 does not belongs to the R. Okay, and then sorry for the disturbance. So give an example of a relation which is reflective symmetric. You can do it by yourself. Okay, give an example of a relation which is symmetric and transitive but not reflexive. You can do it yourself. Okay, problems I will continue. Okay, 30 minutes. Show that the relation R in a set L of all lines in a plane given by, means there are 2 lines. Okay, these are the 2 lines, let's say. So okay, so these are the 2 lines. So these 2 lines are symmetric and these are reflexive. Okay, symmetric is what? 2 lines is perpendicular to, like that. So I will discuss it in another video, I guess. As is a disturbance, you will get distracted, so that's why. So I will continue all this in another session. So I hope you all understood, and thank you so much for watching till now, and make sure to like, share, subscribe. Okay, so these all things you need to understand, and also your work, your task is to complete the NCERT, the exercise first one and second one. If you can do the second one, do it. If you can't, do the first one, and then revise all the topics. And remember, you don't have to get distracted. Okay, I will make a short revision now. So the ordered pair means we are talking about the specific orders, like A and B are specifically like we are representing like the total number of element in the set A and total number of element in the set B. So basically the 2 sets, in that how many number of elements they are present, that's what we are representing in here. And then Cartesian product is what? The product of 2 particular individual sets. So we get a subsets. So that's what we discussed after that. And then what we saw is ordered pair, and how many total number of subset which can be like formed by the 2 particular sets, means A and B are 2 particular separate sets. Okay, the total number of subsets which can be formed by this 2 collision. So what we see is this number of particular sets. Okay, so that's what we discussed. And then what we saw is reflexive relation and symmetric relation and transitive relation. The condition is what? Reflexive relation is A comma A should belongs to the R, and B comma B is also belongs to R, like that. Okay, the 2 first element and second element should be the same to same. Okay, symmetric relation is what? If A and B is there in the relation, they should be B and A. Okay, transitive relation is what? A comma B, if it belongs to the relation, then they should be B comma C, and also they should be A comma C. They all should belongs to R, and all we saying right, A, B, C, they all should belong to the specifically the set from which we made the subsets. Okay, and then equivalence relation, I already told you, all the 3 conditions should be valid. All the conditions should apply. Okay, and all the examples I have already told you, and then this is left, I will tell you in the another class. Okay, thank you so much. Bye bye, and Jai Hind, Jai Karnataka. Okay.